So linear equalities in one variable are things like I have written here. X is greater than 8, x is less than or equal to -1, or 2 is less than x, which is less than or equal to 4. What you're looking for is all of the x's that you can plug in there that will make a true statement. One of the first things we need to get a hold of are all of the different notations, and there are 3 of them that we're going to want to look at. The first one is called set builder notation, and that's essentially taking these statements up here and just slapping some pretty on it. So what we do is we use set brackets, and I'm not a great set bracket maker, but do your best. They're on your keyboard if you're typing. So you do a curly Q bracket saying that it's a set. So it's a set of all x's, and then we draw a vertical line, and we read that line such that, and then you just copy that inequality that you used to have, such that x is greater than 8. Oh, and finish it off with a curly Q. There's my bad one. So the set of all x's such that x is greater than 8. And that's it. That is set builder notation. So if we do that on the next one, set of all x's such that x is less than or equal to -1. So it's just putting some makeup on it. Same with that last one. This is called a double inequality because I have 2 inequality symbols. The x is in the middle, and it's got to stay there even when I copy it over here off my paper. All right, so that's set builder notation. Another way to show these sets to everybody who wants to know what they are is by doing a graph. So I'll go ahead and get my number lines. We graph these on a standard old number line. So x is greater than 8. So I'll go ahead and grab a new color here. I want you to find 8 on your number line. You do not have to show me that you can go from 0 to 8. I will trust that you can. So I'm just going to put 8 on there. And now I need to know, do I go to the right or to the left? Well, I want the x's that are greater than 8, and those are all over here on the right-hand side. So my arrow for my solution set heads that way. Now I need to let people know whether to include the 8 or not. In the past, you might have used an open circle because the 8 is not included, because it's just the x's greater than 8 that work, not 8 itself. Well, the open circle has gone by the wayside, and in its place we have a parenthesis. So parentheses indicate whether a point is included or is not included. A parenthesis says not included. And what I've done is that I've pointed it in the direction that I drew my arrow. And my A got messed up, but that's okay. Okay, so for the next one, find -1 on your number line. There's my -1. I want the x's that are less than that, so that's all over here on the left. But now this time I do include -1, so it needs to differ from that parenthesis to show that it is included. And we do that with a tabbed bracket. That's also on your keyboard if you're typing. And then my arrow goes to the left because that's where the solution set is. A benefit of using these brackets and parentheses is that when your arrow goes right on top of it, we have the tabs pointing that way. So last one, this time
on my number line, the 4 is included, and I need the x's less than that, so I'll put a bracket on that. The 2 is not included, so I'll put a parenthesis and go above, and it's just those numbers in between.
Okay, well, let's go ahead and solve 2 of these and see what we can do, because there is one trick that we'll need to know for solving linear inequalities. So it kind of starts off just like equations. Whatever you do to one side, you do to the other. So I'm going to get all my x's together and all my numbers together. So I'll start by subtracting 9x from both sides. So now I have -12x minus 1 greater than or equal to 7. Add 1 to both sides. -12x is greater than or equal to 8. Here's the new thing. When I divide both sides by -12, when you divide or multiply both sides of an inequality by a negative number, what it does, and I wasn't thinking, is it flips the direction of that inequality. So it used to be a greater than. When I did that division by a negative, it flips and becomes a less than. So I want all the x's less than or equal to negative, let's see, we take the 4's out, 2/3. So if I wanted to graph that, find -2/3 on your number line. I want the x's less than that, and I want 2/3 included. There's a graph. Next one, double inequality. This time I need to keep the x in the middle, but I need to move everything else out. So first I'll move the 6, get the x term by itself. Whatever I do to the middle, I have to do to all 3 sides. So -4 plus 6 is 2. 2 less than or equal to 9x less than 14. And then I still need to get x all by itself, so I'll divide everybody by 9. So at this point I have 2/9 are less than or equal to x, which is less than 14/9. So again, a quick graph. I'm running out of time, so 2/9, 14/9 is greater. I divided by a positive number, so I didn't need to flip. The 2/9 is included. The 14/9 is not, so it gets a parenthesis, and it's all the numbers in between.